Okay, let's unpack this. We've all deployed a YAML file, but, understanding why that file actually turns into a running container that requires a deeper dive.
Right.
So our mission today is really to give that operational X-ray view, the kind of knowledge that helps you debug faster and just design smarter clusters.
Absolutely. And to get there, I think we have to start with the fundamental architectural split.
Okay.
Just think of a cluster as having two main parts. First, you've got the control plane. That's the brain, the executive suite making all the global decisions.
The thing that maintains the desired state we always talk about.
Exactly. And then you have the worker nodes. That's the assembly floor, really. They're the ones actually running the applications, doing the work.
So let's start with the brain then. The front door to that brain has to be the Kube app server, right?
It is. It's the entry point for everything. It exposes all those REST APIs, and crucially, it validates every single request that comes in.
Wait, so if all communication goes through it,
Mm.
isn't that a massive single point of failure? I mean, a real choke point.
It is the gateway. But here's a critical insight. If the API server dies, your running pods don't instantly stop.
Oh, interesting. Okay.
They keep executing what they were told to do. What happens is the cluster, it can't receive new instructions. It can't self-heal until that server is back online.
So it's not like the system crashes, it just becomes deaf and blind.
That's a perfect analogy.
Okay, so the API server is the front door. Where does the cluster actually store what we want it to do? The memory, so to speak.
That would be et cetera. This is the cluster's collective long-term memory. It's a highly consistent, distributed key value store.
And it stores everything.
The entire cluster state. Every pod definition, every secret, every config map, all the node information. If you lose et cetera, you've lost the complete definition of your environment.
Right, you've lost the blueprint.
You've lost the brain itself.
So we have the desire stored in et cetera.
Yeah.
But who makes the placement decisions and ensures that state is even maintained?
Well, that's where you see this amazing division of labor. You have the Kube scheduler. Its only job is placement. It looks at a new pod and evaluates resources, CPU, memory, affinity rules to find the perfect node to run it on.
And the Kube controller manager, that's the self-healing engine you mentioned.
That's it. It runs dozens of specialized controllers, a replica set controller, a node controller, and they're all just constantly watching the state in etc.
So if a pod dies,
the replica set controller sees it. It notices, hey, I'm supposed to have 3 copies, but now I only see 2, and it immediately acts to create a new one. That's what makes Kubernetes so resilient.
that's the powerful brain. So now let's pivot to the worker node, the ground crew taking those orders. We have a few key agents here, starting with the kubelet.
The kubelet is basically the node's local ambassador. It's the agent on every single worker node that talks to the API server. It gets the instructions and tells the local container runtime what to do.
And the container runtime is something like Containered or CRO.
Exactly, the software that actually runs the containers. The kubelet is just the vital interface between the brain and the muscle.
Then there's Kube proxy. It sounds like just some networking plumbing, but I get the sense it's more important than that.
It's absolutely vital. It's what makes the whole service abstraction work. Containers and pods, their IP addresses can change all the time.
And ephemeral, yeah.
Right. Kube proxy manages the networking rules that give you a single stable IP for your service, and it load balances traffic to all the right pods behind it. Without Kube proxy, your apps can't talk to each other reliably.
So we've covered the whole loop, from the brain to execution. Let's end on the pod itself. We all know it's the smallest unit, but why not just run containers directly? What's the key takeaway here?
The pod exists for efficient collaboration. It lets you run multiple tightly coupled containers together.
Like an app and a logging sidecar.
The perfect example. Because they're in the same pod, they can share a network namespace and storage volumes. They're guaranteed to live and die on the same node together. It simplifies everything.
So mastering this whole internal map, it means you stop treating Kubernetes like this magic black box and start seeing it as a system you can actually manage.
Exactly. And it helps you avoid all those common mistakes, like ignoring resource limits or confusing a pod with the deployment.
Which brings us to a final thought.
Right. So given that etc. holds literally everything, every secret, every config, the complete blueprint of your environment, what one operational step, if you ignore it, could lead to the complete unrecoverable loss of your entire application environment.
The backup.
The backup. Religiously backing up, etc. is the essential safeguard. Without that, you've lost the entire cognitive structure of your cluster. A painful lesson to learn the hard way.